The purpose of this practice lab is going to be to find the mass of a dynamics cart by an indirect method. In other words, we're going to find this mass of a dynamics cart without actually using a scale to measure this mass. Now, here's how we're going to do it. At least here's how we're going to pretend to do it. We're going to pretend to push this wheeled cart, this dynamics cart, these carts that you used in Physics 20 from rest. So for every single trial, it's going to start at rest for 2 seconds. Each trial is going to last 2 seconds. Each time we do it, there's going to be a certain force that we apply to this dynamics cart. Each time we do it, the force will be different. We will measure the force each time we do the trial, or at least we'll pretend to measure the force each time we do a trial, and the resulting change in velocity. So 10 trials, 2 seconds for each trial. The force will be different for each trial, and the resulting change in velocity will be different for each trial as well. Let's pretend we've actually collected the data on paper with our group. Now we want to create a spreadsheet within the assignment inside Google Classroom where we're going to transcribe this data. So you can see the assignment on the board here right now. We want to create a spreadsheet within this assignment to transcribe this data. So I've got my data on my paper right now. I'm going to retype this into Google Sheets right now. I know that for every trial, the time equaled 2.00 seconds. That's what we would call control data. That's the same for every trial. So if we have a number for that control data, we're going to record that in our data table. Now, we're not actually going to use that to plot a graph, but you'll see a little bit later on why I've recorded it right there, even though it's not actually part of my graph. Let's start actually recording the data that we wrote down for each trial now. Remember, we recorded for each trial the force. That's what we actually changed. That's going to be in newtons. And the final velocity is what we actually recorded. We want the change in velocity, but we would have recorded with those red and blue dynamics cards the final velocity. Now let's record our actually data here. 1.25 newtons, 2.05. I'm just typing in what I wrote down here. You're just going to use the same data as I did. Over here and fill in final velocity now. 0.9, 1.8. Now, a couple of things you want to watch out for here. You want to make sure that you're using words up here as the column headings as opposed to just symbols. We don't want to write F. We want to write the word force. We don't want to write down V. We want to write down the word velocity. I want to make sure the units are up there in the column headings as well. We don't want to put 1.25 newtons here, because if we do, Google Sheets isn't going to be able to interpret that, and it's not going to understand it. It's not going to be able to plot a graph. So let's just put the numbers in our actual columns. The units need to be there, but they're just going to be at the top of each column in the heading of each column. Now we're going to tidy this up a little bit. Let's make that second column just a little bit wider so that everything fits within there. Let's center this. We're going to do that by highlighting the table and then go over to our alignment here and center it. That looks a little bit better. I still don't like, though, some of this data is to 1 decimal place, some of it's to 2 decimal places. I think what I want to do here, just to make it look a little bit neater, is to highlight that data and then change the number of decimal places. Let's go 2 decimal places so that it's consistent. That's a pretty good looking data table now. Now remember what we said we were going to do. We were actually going to plot the change in velocity versus the force. So I'm actually going to create an analysis table over here beside the data table. The first column is going to be exactly the same. Remember, first table is data. The second table is analysis. But the second table is not going to be final velocity. It's going to be change in velocity. And that's going to be in meters per second as well. Now, this is almost semantics, because in the end, if the final velocity was 0.9, then the change in velocity, because it started at rest, was also 0.9. So the numbers are just going to transfer over there. We'll just copy and paste, Control C and Control V. Now, this is my analysis table. I want to plot this as a graph. So let's highlight it. Let's insert a chart. By default, it will almost certainly give you a scatter plot right up here. If it doesn't, if it gives you a line graph or a bar graph, then just go up to chart type and select scatter chart. You can see here that I've got my axes labeled already. Change in velocity is on my y-axis. It should be, because it was the second column. The second column is always on the y-axis. The first column is always on the x-axis, and so it is. The title is correct. Y-axis versus x-axis, or column 2 versus column 1. Now I'm just going to edit that title a little bit. Double-click it. And I'm going to add in brackets afterwards my initials. I want you to do that as well. That just ensures that you plot the graph, and you're not just copying and pasting somebody else's graph. Now, this is a good-looking graph. Now we're going to add a trend line. I'm going to go over here to Customize, Series. Let's scroll down to where it says Trend Line. The default trend line will be linear, and if that fits the data, then good. If it doesn't, then try a different trend line. Clearly, exponential doesn't fit as well as linear, so let's stick with linear. We can change the color if we want. I like putting it in red, but it doesn't really matter as long as I can see the data points and the trend line. So I've got my graph. But now I have to find the slope of that graph. We always need numbers from a graph. So I'm going to scroll down a little further where it says label. I want you to don't click show R squared. I don't want to see that. I don't need to see that. I want you to go down to where it says label and click custom and change it to use equation. Now you can see the equation there. It just appeared as 0.801x plus 0.0258. Y equals mx plus b, 0.801x plus 0.0258. This is the data, this is the information from the graph that I need. Now, let's do our analysis. We'll get a graph that looks more or less like this. Delta V on the y-axis, change in velocity on the y-axis, force on the x-axis. The trend line was a straight line. We displayed the equation, and the slope of that graph from the equation worked out to be 0.801. 0.801. So let's write that down here. The slope is 0.801. Now let's figure out what that slope represents. We are going to, for this lab and for every other lab we do, and for the graphing question that will appear on your diploma exam, we will always do the same thing. We will create two columns. The first column is titled graph, and the second column is titled class. We need to create an equation from the graph and one from class. Now, the one from the graph is easy. It's always, for a straight line, y equals mx plus b. Remember from math class, math 9 or math 10, whenever it was that you did that, straight line graph always gave you y equals mx plus b. Let's replace y with delta v, because that's what appears on the y-axis of my graph. Let's replace m with slope. Let's use the word slope. Let's not use the symbol m, because we don't want to get m, the slope, mixed up with m, the mass. My x-axis is force. B stands for my y-intercept. But if you remember, the y-intercept of this graph was 0.02, and compared to the numbers on the y-axis, that's really small. So small that we can basically say the y-intercept is 0. So the equation for my graph is y equals mx. We're going to change that, tailor it to this particular graph, and say delta v, change in velocity, is equal to the slope times the force. Now we need an equation from class that has these two variables in it, delta v and f. That equation would be f times delta t is equal to m times delta v, f and delta v. It's my impulse equation. Let's rearrange this equation from class to solve for delta v. Why? Because that's what we solved for in the first equation, was delta v. We just wanted to look the same as the first equation. So let's say delta v is equal to f times delta t over m. We've solved for delta v in the equation from the graph, and we've solved for delta v in the equation from class. Now, and this is where it becomes kind of the crux of what we're doing here, we're going to cross off delta v in both of them simply because that variable appears in both equations. We're also going to cross off f because it appears in both equations. We're left with, in the first equation from the graph, slope, only the slope. And we're left with, in the second equation from class, delta t over m. Now remember what we were trying to do. We were trying to find the mass of this cart by an indirect method. We're solving for the mass of this cart without using a scale. Let's rearrange this and solve for mass. Delta t over the slope. The time, if you remember, the time was 2.00 seconds. And the slope of the graph, that came from the equation that Google Sheets gave us on the graph there, 0.801. We do the math there, and the mass of this works out to be 2.5 kilograms. Remember what we were trying to do? Find the mass of the cart without measuring the mass directly. That's exactly what we've just done. So we've done essentially everything we need to do. We just need to tidy it up into a lab write-up now, into the actual formal lab presentation. So here's what we're going to do now. We're going to go back to the assignment within Google Classroom. We are going to click on the template for the lab. That's always the one with a little purple thumbnail. You can see the purple lines there in the thumbnail. Click on that one. This will tell us what we need to do for this particular lab. Gives us some instructions as well in purple. In the end, we're going to delete all those purple instructions. Just some reminders in there for you when you're writing up a lab, what to do, what not to do, and so on. What's the problem in this lab? The problem in this lab was phrased in the form of a question, remember. We wanted to find the mass of a dynamics cart. So we're going to say, what is, phrased in the form of a question, what is the mass of a particular dynamics cart as measured by an indirect method? Our variables, we've got three sets of variables. There's the manipulated variable, and there's only going to be one of those, right? What's the manipulated variable? Let's go back to our table here. The manipulated variable is the one that we changed. What did we change here? We changed every trial the force. So we're going to say the manipulated variable is the force. We don't need to explain that. We just need to state that the manipulated variable is the force. There is also one responding variable. And that would be, let's take a look over here. Our responding variable is the change in velocity. The first column will always be manipulated. The second column will always be responding. So again, we just need to state that. We don't need to explain it. And the control variables, there's going to be 1,000 control variables, right? But we only need to list the important ones. And it's like sometimes you guys ask, well, how many important control variables do we have? It's a little cheat here. If you go to the rubric inside your assignment, it should tell you right here beside variables, control variables stated, control stated correctly, times 2. We need the 2 important control variables. I don't care if you change the temperature. Technically, the temperature should remain the same, but that's not an important control variable. We needed to keep the time the same. Remember, it was 2 seconds for every single trial, and we needed to keep the mass the same. If we changed either one of those variables, then we would have completely messed up this lab. Variables done. Data? Well, let's say the time was 2.00 seconds. That was control data. It stayed the same for every trial. The mass did as well, but I don't know what the mass was, or at least we don't know what the mass is at this point until the analysis is done. We always want to write down or record that control data, though, if we know that control data. We do in this case. The time is 2.00 seconds. Now, we need to copy over our table here, but let's title that table first. We're going to call this Table 1, Force Applied to a Cart and its resulting velocity. And now let's copy over the table that we typed into Google Sheets already. Move this graph a little bit so you can see that whole table. Copy over force and final velocity. Force applied to a cart and its resulting velocity. Let's link that to the spreadsheet as we copy and paste that. Remember, Control C is copy, Control V is paste. There's our data table. Look, we have our control data, at least as much as we know. The time is 2 seconds. We have our table labeled, force applied to a cart and its resulting velocity. And then we have a nicely formatted data table there. Let's go to our analysis now. The first thing that we're going to do in our analysis is copy over the analysis table. And the analysis table is the force and the change in velocity. Let's Control C, copy that. Let's Control V and paste that. Link it to the spreadsheet. We should title that Table 2. Force applied to a cart and the resulting change in velocity. I got a nicely formatted analysis table, a title there. I don't need to write down time again because I've already done that in my data and I haven't done anything with that time. If you want to put it in again, that's okay, but it's not necessary. Now I want to put in my graph. Remember, my table, my second table, and my graph is analysis. To copy that graph over, I'm going to click on the graph, click on those 3 buttons in the top right corner. Let's copy that chart. Let's go back to my write-up. Control V is paste. Link it to the spreadsheet again. There's my graph. Make sure that I can see that as well. Sometimes you guys like to make it nice and small, and I can't really see the numbers on it. There it is. Now, there's only one more thing that I got to do within my analysis, and that is show that determination of the slope and what the slope represents. So I'm going to go back to the work that I did over here. I am going to copy that. If you did this on paper, all you got to do is take a photo with your phone and then insert it into the document. I'm going to copy over that analysis here. I'm going to go back to my lab right up here. I'm going to go insert. I'm going to insert. I'm just going to go Control V because I copied that. You might go insert an image. There it is. So for you, if you've actually saved that as a JPEG or a PDF, you might need to insert the image. I just literally copied it with the app that I was using, so I'm just going to paste it in there. So now I've got, what have I got here? I've got my data, sorry, I've got my problem phrased in the form of a question. What is the mass of a particular dynamics card as it measured by an indirect method? My variables, that's the force, the manipulator, the change in velocity, it's the responding, and then my two control variables, time and mass. Those are the ones that if I change them, it would mess everything up. I've got my data, time is 2 seconds, that's control data, right? Mass is also control, but I don't know what the value is, not yet. I've got my data table titled and formatted nicely with the units at the top of the columns as opposed to beside the numbers. I've got my analysis, which includes a table and a graph. I've got my table titled, force applied to a cart and the resulting change in velocity. See the table nicely formatted there. There's my graph. The title is correct. Y versus X, responding versus manipulated. My graph is a scatter plot. There's a trend line there. I've got my units labeled there on my X and Y axis. Each axis is labeled. I've got my equation displayed, not the R squared value, but just the equation. And then I've got my analysis to determine what the slope represents and what the mass ends up being. That's it. We're done. At this point, we just need to tidy it up a little bit. Let's go back and delete all this purple. It says here, delete everything in pink, purple, whatever color you see that as before you submit it. Let's delete the purple there. Let's make sure we have it formatted nicely, not with a bunch of extra spaces. Good. Now let's scroll down here and delete this one. Make sure as well that little things like a data table is not spread over 2 pages. So like if your data table is long and it looks like it needs to go over 2 pages, then just start it on the next page. Like this analysis table here, you see that the heading of it is at the bottom of page 1, and then the numbers are on page 2. I'm just going to press enter a couple times, just so it's a little tidier, right? We start something new on a new page. Graph is there, analysis. Okay, we're going to delete this information here. Sometimes we'll have a conclusion, sources of error. In this case, we don't. We're done. Let's double check here. Oh, I missed something here. Replace this sentence with the title of the lab. What are we doing? We are trying to highlight this. That's what we're doing. We're highlighting this and then typing finding the mass of an object by an indirect method. So let's just go through it, just make sure we got everything, the problem, the variables, all neatly formatted, data, observations, yeah, the first graph and the control data, sorry, the first table and the control data there, titled, the analysis, the table, graph, then our analysis of the graph, what does the slope represent, and then from the slope, let's figure out what the mass is. Done. Let's go back to our rubric here now, make sure we got everything. Does it look neat? It's a spelling good. Google Docs does a nice job of spell checking for you. Just go back and make sure nothing's underlined so that you're sure that everything is spelled right. Is the problem stated clearly and correctly in the form of a question? Yeah, it is. Is the manipulated variable stated correctly? Responding control variable stated correctly? Yep, at least we think so. Is all the relevant data collected with no extraneous data? Is the table titled? Yes, it is. Force applied to a cart and its resulting velocity. Are the units recorded? Yes, they are. For everything, including the control data. Is it presented neatly and organized well? Yes, it is. Is the analysis table provided? Yes. Is it titled? Yes. Is there an appropriate graph with the axis correctly positioned? Yeah. In other words, do we have our axes reversed? No. My first column, Force should be on the x-axis, and it is. So those are correct. Do we have the proper title, including my initials? Including my initials, yes I do. Change in velocity versus force, BD are my initials, that's good. Is there appropriate analysis? That would be this stuff down here, the stuff that I copied and pasted over. The two columns, graph and class equations, and then what you do with those to get the mass of this. So I've got that there, and it looks to be correct. Graph is titled, yeah, the graph analysis, the trend line, the slope, the significance of the slope and the application. So the calculation of the mass, the units are recorded. And did I record the units for that? In kilograms, yes, I did. And is it presented neatly and organized well? I think it's presented pretty neatly and organized pretty well. I think I'm done. Now all I'm going to do, now that I'm confident that it's done well, I'm just going to click Turn In. And I'm going to go watch some Netflix.